Bismillahirrahmanirrahim. Welcome to the first part of the 8th lecture of Statistics and Probability Theory. In the previous lecture, we were studying random variable, a real valued function assigned to a sample space of a random experiment is called a random variable. There are two types of random variable: discrete random variable and continuous random variable. Whenever we have discrete random variable, the probability distribution from that particular random variable is called discrete probability distribution or probability mass function. In previous lecture, we have studied discrete probability distribution and cumulative probability distribution of the discrete random variable. In today's lecture, we will going to cover expected value and variance of discrete random variable and continuous probability distribution. Expected value and variance of discrete random variables. We already know that whenever we can count something, it is discrete, and the variable is something which is not fixed, like number of sales, number of phone calls, number of students in a class. All these are discrete random variable. How can we find out the expected value and variance of the discrete random variable? The expected value, or we can say its mean, of a discrete random variable is defined as mu. Mu is a Greek letter, is equal to expected value of x. X is the particular random variable we are discussing, is equal to summation x into p of x. This x is the particular value of the random variable and p of x is its occurring probability. The variance of a discrete random variable is a measure of variability and is defined as sigma square. Sigma is a Greek letter which we represent for the variance. Sigma square represents the variance, is equal to expected value of x minus mu whole square, which is equal to summation x minus mu whole square into p of x, where mu is expected value of x. How we can find out this? Now, we have discussed this particular example in the case of cumulative probability distribution function. We are taking the same example where f of 0 is equal to 1 over 16, f of 1 is 1 over 4, f of 2 is 3 by 8, f of 3 is 1 by 4, and f of 4 is 1 by 16. Here we know that x has 4 values: 0, 1, 2, 3, and 4. Its probability is 1 by 16, 1 by 4, 3 by 8, 1 by 4, 1 by 16. I have already mentioned in previous slides that f of x is equal to p of x, as we are discussing probability distribution function. F of x is basically giving us the value of the function whenever we substitute the value of x. Here the function we are discussing is basically the probability distribution function. So whenever we substitute the value of the random variable, it will give us the probability for that particular value. So we can write p of x instead of f of x. Now we have to find the expected value of x. How can we find out it? Expected value of x is equal to summation x into P of x. So it means first we have to find out this x into P of x, and then we have to sum all these values where I is equal to 1 to n. It means you have to sum on all the values of the random variable x, as x is a random variable, so it possesses different values. So we have to generate the column x into P of x. Here x is 0, and P of x is 1 by 16. So x into P of x is 0 into 1 by 16. Here x is 1 and P of x is 1 by 4. So x into P of x is 1 into 1 by 4. Similarly, you can generate the whole column. By summing up this column, you will get summation x into P of x, which is 2. You will add all the values coming from these calculations. It will end up with 2. So the expected value of x, you can say it mu 2, is basically mean is equal to 2. Now you have to find the variance, which is sigma square is equal to summation x minus mu square into P of x. This is the one form of the or one type of formula to find out the sigma square. It can be further simplified as summation x square into P of x minus summation x into P of x whole square. This is the simplified form of this particular formula. You can generate it easily by simply substituting mu is equal to summation x into P of x. Then you will open this square by using the formula a minus b whole square. By simplifying this, we can get this particular formula. So we can use both these formulas, as this one is the simplified form. So I will gonna use this formula. Now, whenever we have a formula, we have to find the particular things mentioned in the formula. We have summation x square into P of x minus summation x into P of x whole square. We already have summation x into P of x. This is 2. So we have to find out this thing, summation x square into P of x. So first we have to generate the column x into P of x. X square into P of x, x square into P of x. Here x is 0 and P of x is 1 by 16. So it is 0 square into 1 by 16. X is 1 and P of x is 1 by 4. 1 square into 1 by 4. 2 square into 3 by 8. By calculating whole this column and by adding this, you will get summation x square into P of x, which is equal to 5. So by substituting these values in this particular formula of the variance, we can find out the variance of this particular random variable. It will show the variability in the random variable. We know that this value is 5 minus summation x into P of x is 2. and we know that its whole square is there, so it is 2 square, which is equal to 5 minus 4, which is equal to 1. So this is the variability of this particular random variable. You can find out the standard deviation too. As you know, the standard deviation is the under root of the variance we have discussed in previous lectures. So this, by taking the square root on both sides, we will get the standard deviation, which is also 1 in this particular case. By this way, you can find out the mean or expected value and variance of the random variable. Example number 2. This is the same example as we have discussed in previous lecture. A shipment of 8 similar microcomputers to a retail outlet contains 3 of that are defective. If a school makes a random purchase of 2 of these computers, find the expected mean and variance. We have already generated probability distribution function for this particular example in previous lecture. Here we have to find the expected value and variance of the random variable, and the random variable is the defective computers. We have to find the variance and expected mean for the defective computers. So we have 3 defective and 5 non-defective, where total we have 8 computers, from which we have to randomly choose 2 computers, and x is equal to number of defective. We have already generated the probability distribution function for the defective computers in lecture 7, or if you want to recall, you can go to the lecture 7. We have explained this example in detail in that particular lecture. Now, we will go further. As you know that x is the number of defectives, and we have discussed there could be values of x, 0, 1 and 2. This 0 is basically small x1. This 1 is basically small x2. And this 2 is basically small x3. Now, we know that probability of x is equal to 0 is 10 by 28, x is equal to 1 is 15 by 28, x is equal to 3 is 3 by 28. We can find out the expected value of the random variable x by generating the column x into p of x and then summing up it. That is summation x into p of x. We already know that x and p of x, 0 into 10 by 28, 1 into 15 by 28, 2 into 3 by 28, which is 0.75. And variance You can find out the variance of this particular random variable by substituting the values sigma square summation x square into p of x minus summation x into p of x whole square. You can find out summation x square into p of x by summing up this particular column x square into p of x. You can find out this by simply taking the first value of x, which is 0, and taking its square, 0 square, into its probability 10 by 28, 1 square into 15 by 28, 2 square into 3 by 28. By adding whole this column, you will get 0.964, which is equal to 0.964 minus 0.75 whole square, which is 0.40. This is the variance of the particular random variable. You can find out its standard deviation by taking the square root on both sides, which is 0.402. Sigma is equal to 0.6 double 0.634. So this is the standard deviation of the random variable.